Today's lesson is about solving real-world problems that involve multi-step operations with rational numbers. So the learning target states, I can solve multi-step real-world problems using addition, subtraction, multiplication, and division of rational numbers, including positive and negative integers, fractions, and decimals. So now we're incorporating those negative numbers, still working with fractions and decimals, and still working with all of those operations. So we're going to kind of dive into our first scenario. And whenever we attack a story problem, I always like us to think about actually being in the problem. So this problem says you walk into a store with $40. You buy a sweatshirt for $18.50, return a shirt you bought last week for $12, and then you grab a smoothie for $6.75. Do you have enough money left for a $10 beanie? So when we look at these story problems, there's a lot of numbers and a lot of things happening. So let's kind of just take it like step by step and think about where are you starting. So when I'm looking at the problem, I see that I am starting with $40. So I walk into that store and I have $40. So that's going to be kind of where I start. Okay, that's how much money I have. And then I read on and it says you buy a sweatshirt for $18.50. So I'm going to stop there and I'm going to see how much money do I have after buying that sweatshirt. So buying a sweatshirt, $18.50. I'm going to take 40. I'm going to subtract $18.50. So I do 40 minus $18.50. I'm going to be left with $21.50 after buying that sweatshirt. So then I'm going to move on and it says, okay, I'm going to return a shirt. So if you haven't returned a shirt before, that just means that I'm giving the shirt back to the store and I'm going to get my money back. Okay, maybe I didn't need to wear it anymore. Maybe it was the wrong size. Who knows? But returning a shirt for $12 is going to be the next thing. So I'm going to take that $21.50 and I'm going to subtract 12. Oh, not subtract. Sorry, I'm going to add $12 because I'm returning the shirt, meaning I'm getting that money back. So when I add $12 to what I had before, I'm going to have $33.50 now. And then I'm going to just keep reading on and see what happens next. And then you grab a smoothie for $6.75. So if I'm grabbing a smoothie, that means I'm paying someone for that. So again, I'm going to take where I ended up. So I ended up with $33.50, and I'm going to subtract $6.75. And my total would then be $26.75. And then the last part of my problem says, do you have enough money for a $10 beanie? So when I look at my total, I have $26.75. I definitely have enough money for that $10 beanie. When you go to actually answer the question, you kind of look at your numbers and you always want to write a complete sentence because sometimes your answer might change, meaning your math answer and then like your real world complete sentence response might be a little bit different. And we'll kind of look at an example later. So I'm going to write, yes, I have enough money left to buy a $10 beanie because I have $26.75 left. Okay, your sentence might look a little bit different, but just kind of showing that, hey, I have enough money. This is how much I have. This is how much I need. You could go a step further and say, after you buy the $10 beanie, how much money you'd have left. But all it simply asks is, do you have enough money? And the answer would be yes. So when we look at the notes below, just want to kind of summarize how do we actually make sense of these real world problems and specifically these multi-step problems. So for me, the first thing I always do is I would read the problem like a story. So I would read it like a story. Put yourself in the situation. And then the next thing you want to do is, in most cases, you're going to want to follow the order of events. Okay, thinking about what happens first, next, last, thinking about what we were starting with. You're going to follow the story, not the order of operations. When you're looking at that order, you're going to want to identify the operations, like are you adding, subtracting, multiplying, or dividing? And then you're going to also want to identify any integer signs, meaning positive numbers have to do with like increasing, gain, rise, above sea level, above zero. And then you have your negative numbers that might be decreased, lost, owing, dropping below sea level. And then the last thing is you might want to use a visual model to stay organized if needed. So that could be a chart, a diagram, pictures. And then lastly, always answer that question and then also interpret the question, making sure you're actually answering what the question's asking. And then always, always, always at the end, double check, does my answer make sense in the real world situation? Should my answer be positive or negative based on the story? Okay. Before we dive into the we do problems, I have kind of just a section on like stuck on how to start. Ask yourself a couple of these questions. I know sometimes when you see a story problem that has a lot of numbers and a lot of things going on, it might, some people might feel a little frozen about where to start. And I know that sometimes getting to start is kind of a student's largest problem. So think about when you go to start the problem, think about where you're starting the problem, meaning like what is the starting value? Is it how much money you're starting with? Is it how much snow has fallen? Is it how much you've bought, how much you have? And then thinking about what's happening next and kind of just take it one step at a time, maybe cross out parts of the story. Thinking about, is there words that tell you if that number is actually positive or negative? And kind of annotate as much of the problem as you need to. Use models to keep it visual, like drawing pictures or charts. But kind of use some of those prompts if you're not sure how to start. So we're going to look at the first we do problem, and it says a teacher bought 18.5 pounds of clay. Each student uses 0.8 pounds for a sculpture. If there are 23 students, does she have enough? If not, how much more does she need? So for this problem, I know the teacher has this much clay, and I'm trying to figure out, does she have enough? So what I'm going to do is I want to see, based on the information they gave us, if she has enough. So what I know is that each student uses this much clay, and there are 23 students. So student 1 would need this much clay. Student 2 would need that much clay. Student 3 would need that much clay, and so on and so forth. So I need this much clay for every student. A quicker way of all that repeated addition is simply to multiply. So if I have this much clay for every student, I'm going to do 0.8 times 23 students to figure out how much clay I'm going to need for all of those students. So when you multiply decimals, remember you can ignore the decimals right now. So I'm going to pretend like it's just 23 times 8. 8 times 3 is 24. 8 times 2 is 16. Plus 2 is 18. So I have 184. Then look back at my original problem. I have one number to the right of the decimal place in total of both numbers and both factors. So I'm going to take my decimal that would normally be here, and I'm going to move it one spot to the left. So 0.8 times 23 would be 18.4. And this stands for, I need 18.4 pounds of clay for 23 students. So based on that, if I look back at my problem, the teacher bought 18.5 pounds of clay, and that's going to be greater than the 18.4 pounds of clay needed, meaning that she bought enough. So I'm going to go ahead and answer the question, which is yes, the teacher has 18.5 pounds of clay, which is enough for 23 students who will need 18.4 pounds of clay. Again, your sentence could be a little bit different, but just again showing how much pounds of clay that was bought and how much that is needed. Now, obviously, doesn't account for any students maybe making a mistake or for a teacher to even do a demonstration. But again, the question is asked, does she have enough? And the answer simply would be yes, based on the math. So let's look at the last we do problem. It says an ice cream shop has 14.5 gallons of ice cream. Each cone uses 0.2 gallons. If 3.8 gallons melt accidentally, how many cones can still be sold? Notice how I'm reading the full question instead of just diving in right away. And this is a good example of kind of showing how things don't always go in order. Okay. And so I noticed that there's 14.5 gallons of ice cream. I know how much each cone of ice cream is needed. But an important thing that they start off saying here is that this is how much ice cream melted accidentally right away. So even though it's telling me I'm starting with 14.5 gallons of ice cream, the problem clearly states that what happens if this much ice cream melts? How many cones can I still sell? So I'm going to immediately start with subtracting how many gallons of ice cream. If 3.8 gallons of ice cream melted, how many gallons do I actually have? Because I don't have that 14.5 anymore. So when I subtract 14.5 minus 3.8, I'm left with 10.7. So that's how many gallons of ice cream I really have, for that day, that weekend, whatever time frame that is. And then I'm going to use that amount. To determine how many cones can be sold if each cone uses 0.2 gallons of ice cream. So I'm going to take that 10.7 and I'm going to divide it by 2. I'm going to divide it by 0.2. So I want to see how many times 0.2 can essentially fit into 10.7. So when we divide decimals, a couple of different ways to approach it. For me, I'm going to just multiply both by 10 to kind of get rid of that decimal. And I'm going to treat this as 107 divided by 2, actually. And that's a lot easier number for me to work with. Remember, I'm multiplying both numbers by 10. I'm not really changing the value. I'm just kind of making it a problem that's a little bit easier to work with. So I'm going to take that 107 and I'm going to put 2 on the outside. 2 goes into 10 5 times. 5 times 2 is 10. 10 minus 10 is 0. Bring down my 7. 2 goes into 7 3 times. 3 times 2 is 6. 7 minus 6 is 1. Gonna form my decimal. Make a 0. Bring that down. 2 goes into 10 5 times. 5 times 2 is 10. And then I'm left with 0. So 107 divided by 2 or 10.7 divided by 0.2. Either answer is 53.5. So my math answer is 53.5 cones of ice cream can be sold. Now that's my math answer. At the beginning of the video, I talked about how sometimes there's a math answer and a real world answer. So if I'm a business owner, I wouldn't be selling half cones. I would be doing my budget. I'd be doing my math based on selling whole cones. So when I'm looking at, okay, I have enough ice cream to sell 53.5 cones. But what that really means is that I can only sell 53 cones. So I would write the ice cream shop can sell 53 ice cream cones. So That's another thing. We have to answer the question that makes sense. Always check if your answer makes sense. The ice cream shop cannot sell 53.5 cones. Guess is how many they can make, but how many they can sell would only be 53 ice cream cones. So now it's your turn to try. There's 3 more questions on the you do side, and do your best, reference your notes, reference those kind of reminders of how to start a problem, draw pictures if you need to, use charts, think about all the different strategies you can use to kind of start to tackle these problems. If you have any questions, be sure to ask your teacher and check with your teacher for the answers. Good luck.